So in this video, we're going to cover the process of how we train our AI model, go through a quick example of what the model can do, and cover our next steps. So the first step that we had to do was collect data so we can use to train the model. Collecting the data was done using two different methods, web scraping and public data sets. For web scraping, we used a variation of different websites such as travel forms, tourist websites, public reviews, travel requirement websites, and websites that have data on transportation as well as hotels. For public database, we used open source data sets that are available on platforms such as Kaggle, and we gathered data sets that provide information about Canadian attractions, weather data, public transport data, geopostal data, and general information about Canadian tourism. Now the goal with our initial data collection was to gather general data so we can actually start training the model. Our next step was structuring and pre-processing our data. To do this, we first had to structure the data into categories, and we split things into like accommodations, restaurants, transportations, and so on. We then made a processing pipeline that standardized the data. So for example, if one data set for restaurant had a field called restaurant name, and other data set for restaurant had the same field titled business name, we will merge the standardized data sets so that the field name is the same. We then merged the data from web scraping and public data sets that we had, and we also did data cleaning. So for example, removing duplicates, removing empty fields, and so on. Our next step before we could begin training the model was selecting the best large language model for us to use. There were a lot of options such as Gemini, Mistral, and Cohere, all of which are good for specific use cases, but in our case, the best model for us was GPT 3.5 by OpenAI. It provides great conversation capabilities and is very versatile and can be used across many cases. In the future, we'll incorporate newer versions of the model such as GPT 4.0. So after we gather all the data, we start feeding it into the AI so we could begin our prompt engineering process. The idea of prompt engineering is simple. We had to create very specific prompts to guide the model so it can give the best responses using all the data that it has. We started with setting very clear instructions to guide the model. We also incorporated things like time and budget constraints, and we tried different wording for prompts. For example, instead of asking AI to tell us best things to do in Toronto, we would ask it to provide best museums to see in Toronto with explanation of why each of these museums is worth visiting. We also used prompts that had different types of travel preferences, such as different budgets, food preferences, family-friendly options, and so on. We used all these prompts to test the way the model responds. We evaluated the accuracy of the results as well. Based on all the prompts and responses AI has given, we understood that our model was not as advanced as it should, and the quality of responses were not as good. And based on the results we saw, we decided to fine-tune the model because it was clearly lacking knowledge in specific fields and could not accurately answer some of travel-related questions. Which makes sense because our initial data sets were more generic and model could not provide accurate responses consistently. We began the process of fine-tuning model by gathering some more focused data sets. With location-specific information, we also gathered labeled data sets that provide the model with examples of typical travel plans and preferences and activities most travelers enjoy. We also improved the model's contextual awarenesses so it could respond better to individual preferences like budgets and travel styles like active travel. We then further defined our benchmark for evaluating the model based on its responses, relevance, and diversity of its responses, and model's ability to interpret complex user questions. After fine-tuning the model and re-evaluating our benchmarks, we reviewed our prompt engineering process and improved the prompts. We repeated our prompt engineering process with new data and updated benchmarks to further train our model and improve its responses. This process of prompt engineering the model, evaluating the results, and fine-tuning the model is something we will continue repeating until we're satisfied with the results and we also truly believe the model can be deployed. And now I will quickly walk you through an example of how a user can plan their trip on our platform. Before I get into the actual example, the main idea of this demo is to show that our model is able to respond to the user prompts, provide recommendations based on personal preferences, and adjust the responses as the conversation goes on. This was achieved through the datasets that we fed into the model and through prompt engineering and fine-tuning process. But we still have a very long way to go before we can show the platform to our users. The core idea of MapleTrip is to create and automate end-to-end travel planner. In the future, our model will use trip information and personal preferences to provide an extremely detailed trip plan, not only with general things to do, but with hourly schedule, pre-selected flights, hotels, transportations, and restaurants, along with reservations. All the users will have to do is review the provided plan, make adjustment if needed, and they will be able to book in the entire trip with just one click of the button. Of course, getting there will take a lot more development, and for today's video, I will show the current progress of our model. So in this example, I have already planned most of the trip, and I will quickly walk you through the AI decision-making process. So the first question the user asks is that they're planning a trip to Toronto with their wife and 2 kids. They plan to stay here for 3 days and they would like to do a lot of sightseeing because it's their first time in Toronto. And they ask AI to create a full trip plan for them. So AI does exactly that. It splits the trip by days and creates detailed trip plan for every single day, starting with things like seeing CN Tower, the aquarium, and even suggesting places where they can grab lunch. It then provides the entire plan and even provides additional tips about weather and transport. Then the user asks a second question, asking what good vegetarian restaurants can they try. This shows that the model is able to not only respond to the questions, but follow an actual conversation as well. And then using the data that we fed into the model, our AI provides a list of restaurants that are vegetarian friendly, and it provides a short description for each of these restaurants. Then the users ask to change their trip plan and include these restaurants for breakfast, lunch, and dinner every single day. And they specify that these restaurants have to be close to where their family will be on that day. And so once again here, the model does exactly that. It repeats the same travel plan for 3 days, and now it also mentions places where the family could eat while they're exploring the city. This shows that the model is able to understand complex questions and update information that has already been provided. And again, this is all based on the data sets that we provided to the model. Then the user asks, what are some good places where they can take their kids? And they specify that the kids do not like museums. Once again, this relates to our part of training where we focus on user-specific preferences, travel styles, and made it possible for model to provide suggestions based on these preferences. And here, the model actually does not provide the best suggestion. It suggests them to go to Toronto Islands, which is a family-friendly place, yes, and most kids like the outdoor places. But the issue with this is the winter is pretty cold here, so the suggestion would not really be the best choice. The user asked to provide something else, and the AI suggested the Legoland Discovery Center. So this shows that the model is able not to only provide suggestions based on user preferences, but it can also adapt. But it does show that there is an issue with our suggestion because at first it suggests a place that was not quite ideal for the winter trip in Toronto. This basically goes on to show that we need to do additional training for AI and feed it more data sets. In this case, weather data sets, and correlate it with seasonal attractions. This way, we will be able to improve the model's results. Then the user asks what would be 2 good hotels for them to stay in Toronto. and they specify that they're only looking for 5-star hotels. Once again, this is budget and lifestyle preference that our AI takes into account. Model then says they can visit Ritz-Carlton or Four Seasons Hotel, both of which are 5-star hotels and some of the best in Toronto. So from this demo, we can see that our AI is able to understand the prompts given by the users, and it can provide accurate suggestions based on user preferences to create a full trip plan. On top of that, it can also adapt based on questions that a user asks. It can update travel plans, change specific restaurants or specific activities that a person does not want to do. Now let's ask another question to show how it works in action. Let's ask how can I plan a trip from Pearson Airport to Toronto by public transport? That's what I'm going to type. And now the AI is analyzing our user input. Keep in mind that this is one of the things that we're looking to speed up in near future, because as you can see, the AI does take some time to actually understand the prompt and provide a response. So now we can see that our model is telling the traveler that a good way to get from Toronto Pearson Airport to the city by public transport is use the Union Pearson Express, which is the correct option. It also provides the cost of taking this train and additional information such as frequency and the time it takes to get to the city. It also lists the steps that you have to do to get to the train station at the airport. This is done based on the transportation and geospatial data that we used for training the model. The whole idea of showing this demo is to demonstrate that our AI is capable of understanding user prompts and providing accurate suggestions with details to create full trip plans. Now, in the future, of course, we'll focus on improving the suggestions that we provide, making them even more personal, and we will do this through fine-tuning and prompt engineering. Of course, we're also going to focus on the design aspect of our user interface to make it more interactive and visual. Then we'll also integrate live information about flights, hotels, and transportation, and allow users to book it directly from the platform with one click based on their customized plan, from flights and hotels and restaurant reservations, all in one click. These are some of the development goals that we have in the near future.